When you flex, you're really flexing chemistry. Before you get a protein, you need a folded polypeptide. And before you get a polypeptide, you need a peptide bond. Let's build one, starting from the atom up. Amino acids are the basic units of proteins, like Lego blocks. Each has a standard structure. It will be a molecule with an amino group, NH2, a carboxyl group, COOH, a hydrogen, and a unique R group, all bonded to a central alpha carbon. Each R group is different. That's how we get 20 unique amino acids. It's biochemistry's starter pack. In order to link two amino acids, we need a special chemical move, the nucleophilic attack. Nucleophilic substitution is when an electron-rich atom, or nucleophile, donates a pair of electrons to an electron-poor atom, or electrophile, forming a bond. The nitrogen in the amino group of one amino acid goes full ninja, attacking the carbonyl carbon of another. A peptide bond is just a covalent bond between the carboxyl group of one amino acid and the amino group of another, forming an amide linkage. You lose water in the process. That's dehydration synthesis. Congrats, you've made a dipeptide. Now let's zoom in on that bond. This isn't just a regular bond. The peptide bond has vibes, specifically resonance. Resonance delocalization is just electron sharing across multiple atoms that gives extra stability to a molecule. Electrons from the nitrogen sneakily delocalize toward the oxygen. It's like the bond almost becomes a double bond. That double bond-like character makes the peptide bond flat and rigid, forming a sort of planar bond where there's restricted rotation and it forms that flat structure. But the chain isn't a stiff rod. Rotation happens around the alpha carbon, the central carbon of an amino acid, bonded to the amino, carboxyl, hydrogen, and side chain groups. This alpha carbon is going to allow rotation in the backbone. Stack more amino acids, and you get a polypeptide chain. A polypeptide is literally just a chain of amino acids linked by peptide bonds. Zoom in, and you'll see a repeating pattern. Nitrogen linked to the alpha carbon, linked to the carbonyl, and it repeats. The amino acid chain always starts at the N-terminus, the amino end, and ends at the C-terminus, the carboxyl end. If you're wondering what residue means, it's just an amino acid within the polypeptide chain. Say you want to break a peptide bond. You have two tools. The first is a form of hydrolysis, a reaction where water is added to break a bond. Option 1 to break a peptide bond is acid hydrolysis. Throw in strong acid and heat. You'll get all the amino acids, but in random pieces. Option 2, proteolysis, the surgical strike. Proteolysis is enzyme catalyzed cleavage of peptide bonds at specific sites. Now, on the topic of breaking peptide bonds, I'd like to introduce you to trypsin, the hitman of the pancreas. Trypsin is a protease that cleaves peptide bonds on the C-terminal side of arginine and lysine in a process of proteolysis. Give trypsin a chain like the example at the bottom, arginine, alanine, lysine, glycine, and trypsin will slice after the arginine and lysine only. Precision protein dissection. Peptide bonds might be small, but they're the foundation of everything, from enzymes to antibodies to the muscles in your arms. Thanks for watching, and I hope you enjoyed. Please leave a comment for suggestions and future videos.